Okay, so today we're going to be looking at server-sided variables and how they work and that kind of stuff. So, first things first, server-sided variables are very, very easy to integrate as long as you know basic networking, okay? Now, preferably for something like server-sided variables, you want to use the TCP protocol or preferably not HTTP because there's going to be a lot of people that think that the integration for this is going to be through something like HTTP. HTTP is perfectly fine to use for something like this, but it's also terrible because performance-wise, you're going to run into a lot of problems. So, first things first, server-sided variables. They're essentially variables that are not hosted directly on the published software. They're hosted on a remote server, and the remote server is sending the variables to the client software whenever the client software requests these variables be sent. Now, you don't need to store every single variable inside of the server or inside of the server side part of things. We're going to get into how to store them and what kind of like parameters to store them in and stuff like that in a little bit. But right now, I'll talk about the basic stuff. So, you don't need to store every single variable server-sided. You just need to store or preferably you should just store the sensitive variables or variables you don't want other people to get their hands on, such as authentication codes, stuff like that, stuff that shouldn't be hard-coded into your software regardless. And a good example of this is using a database because obviously with a database nothing's hard-coded, you can always change it and whatnot, but you want the risk factor of someone actually finding the database credentials, then hacking your database, and shit just goes sideways from there. But with server-sided variables, it's kind of a workaround because you can store them in a database as well as, fetch them without running the risk of someone decompiling your software or perhaps listening to network data that's receiving in and out. And finding your endpoints and then attacking you. They can do it with this obviously, but we're going to walk through some cool little ways to mitigate this. So the first thing we're going to look at is variable storage. Okay, now when we store variables, we're going to be storing two main things. Okay, we're going to be storing a key value and we're going to be storing a value. Now the key value is the identifier for the variable. Now, when you create a variable, realistically, you're going to be creating something, let's say string, then we have the ID, which is the identifier for this variable, is what the variable is called, and then we have the value of the variable, which would be right here. Now, rather than us directly storing string variables and whatnot server side, let's say we're using a hash map or something like that, and we're storing the variables with ID and value inside of a hash map. Now you can do that, don't get me wrong, but it's not as efficient as using something like a database like MySQL, or it's really I prefer SQL databases, so you guys can use any database structure you want, any database that you're personally familiar with. I'm a MySQL developer, so I fuck with MySQL a little bit. But we're going to be storing two things: the key and value. The key is the ID parameter. It's how we know what our variable is called. Now let's give an example variable here. Let's say we have the key name, and then we have the value. Let's say Aaron. Okay. Now, whenever we send a request to our server with the variable ID name, it's going to return Aaron because that is the variable that is there. Now, realistically, you could have a database structure or table structure that contains a key and a value column so that you can actually fetch this dynamically without having to go through the whole hassle of changing code whenever you want something changed or going through any of that. I don't need to explain to you guys why it's good to use the database, okay? But yeah, that's essentially how to store it. Okay, now obviously you could store other information with this. You could store the data type that you're storing. So this is a string, so we'd probably have a data type variable or a data type column that specifies what kind of data type this is. So this would say string, etc. But obviously with MySQL and stuff like that, you can set your own data parameters. However, there's different cases for different things. You might want to store just strings so that you don't need to go through parsing and whatnot for every single variable, because you may store an integer and you need to make sure that you know what the value is before you put it into the database, so that you know what data type to make it, etc. And it just becomes a big hassle. So you probably want to store the data type as well, but that's up to you. Once again, it just depends on how your system works. Now we're going to look at how to kind of integrate this into your software and how to strengthen it so that it's difficult. It's not impossible. It's not impossible, but it's difficult. It's very, very difficult for them to crack, for them to break into. Because realistically, you're always going to have the problem where people know where you're sending requests to, because at the end of the day, you're sending it from their network. They can always see that information, guys. Now, the best way, in my opinion, to handle this is to simply create a socket between, or a stable socket between two different endpoints. Now this is going to be the server side and the client side, okay? So I'm going to quickly draft up the server side here, and then we're going to draft up the client side, and we're going to have a look at how we're going to communicate between the two. Client side. Now, most people would simply set up a HTTP server that follows the general structure we've kind of just laid out, and then make requests with a variable parameter or an ID parameter every single time they want to get a variable. Now that's fine, you could probably do that if you're running a small application, go ahead. But the thing is, you're going to run into problems such as resource consumption, because if you're consistently making requests, you're going to see that the computer that the software is running on, or the client, is going to be having some performance issues depending on how many requests you're making. Now, obviously, this will depend per client and per specs, obviously, but realistically, you don't want to develop software that is shit when it comes to performance. Okay, you don't want to, regardless of anything. So, it's definitely important to make sure you get performance down for everyone, to make sure it's good software. It's good software. Okay, now, there's the one way that I would always recommend everyone to do it, and that's using TCP. Now, what we're going to be doing here is we're going to be setting up a server in the server side. Okay, this server is just an endpoint the client is going to connect to and send data back and forth with. So let's assume we've set up a nice little server socket here. If you guys don't know how to use how to set up servers and TCP servers in Java, or not even in Java, in any language really, because this is kind of for everyone. So I'm personally a Java developer, so if you guys are Python developers, whatever, I'm assuming you guys know how to set up TCP servers, or have some kind of understanding of it, and I'm sure you guys can understand you guys can learn how to set one up if you need to. But let's assume you have the knowledge. What we're going to do is we're going to set up a server on the server side, and that way our client can essentially build a bridge between the two endpoints. Okay, this means they're connected to each other now, and the client will be able to see this. If they decide to packet sniff or whatever, they'd be able to see that there's an outgoing connection between the client, between their computer, their network, and the server that you're connecting to. So remember that, guys. So obviously this does come with other risk factors, such as if someone does send, let's say as an example, a denial of service attack to your server that your variables are hosted on, none of your other clients will be able to fetch data from that server, which may cause issues with your client side, depending on how your server side is set up. Maybe you have multiple maybe you have multiple endpoints just in case of this kind of thing. Maybe you have your own DDoS protection. You could use providers such as OVH, such as providers that generally provide you with great DDoS protection, and generally just create something like that is secure, so that this kind of stuff doesn't happen, because this is a risk you're going to get. Server side, when things become server side, shit becomes hectic. Okay, it does. That means everything relies on the server. If the server's down, everything's down. Okay. And that can be scary for new developers or developers that aren't too interested in maintaining a platform and just want to develop software and release it. So this is something that you definitely need to do with caution, okay, guys? Now, whenever the client wants a variable, we're going to keep in mind, we're always going to, these variables are going to be stored on the server side. We're going to be assuming we have a bunch more variables here that are stored on the server side, okay, but for this video, I'm not going to be creating a bunch of variables and then paint, but What we're going to do is whenever the client wants to fetch a variable, let's say we want to fetch the name variable, we're going to send some data over to the server side and we're going to say, do you know what, send me the name, send me the name. We're going to send a name packet. Let's say a packet that contains a string that just says name. Now on the server side, we could set up so that it just listens for identifiers. So once it receives any data, it instantly tries to parse it and check if it's a variable, and if there is a variable that goes by the identifier that the client side had sent through, then it would return that back to the client and say, okay, yeah, we found that variable, so here you go. Now, there's one cool thing to it. You guys will be wondering, why is this so performance efficient? Why not just use HTTP at this point? Because this connection between the server side and client side is never going to drop. We're going to make sure it doesn't drop, essentially. We're going to keep this consistent connection open, and whenever we need a variable, we're going to quickly access it and send some data over. Okay, we're not going to be closing and opening a new connection every time we want a variable. We're going to keep this connection open consistently, send data over back and forth, and however we want to. Now, you can do this through HTTP as well by creating, let's say, another server side that connects between two data. So essentially, three endpoints. So it's one endpoint, then we have the client side, and then we have the middleman, REST API slash web HTTP API, whatever you want to call it. So this is server side, this is the website, and this is the client side. Okay. Now the one way you could do it is that the web server and server side have a consistent socket between them, so that they're always transferring data as we did in this example where we send a request for an identifier, and if that identifier exists and there's a variable with that identifier, then we return that identifier to the web server. What we could do is make so the client will make a new connection every single time it wants to fetch a variable, and in that request it's going to contain the ID parameter on what they want, what variable they want, and then the web server is going to check with the server, blah 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 blah. That's a really good way to do it, because with websites, generally with layer 7, you can set up a lot of protection in regards to DDoS attacks and stuff like that, and generally security, because you can't just have your server IP or the IP that off the server that's hosting most of your important shit. You can't just have that lying around, because that can really fuck you up, especially if you get hacked or anything like that, guys. So keep that in mind. Now, doing it this way, you can use Cloudflare, you can do a bunch of different things, but most importantly, you're keeping your server side safe. You don't want that to get into the wrong hands, guys. Now, we're gonna look into some cool little authentication methods. Now, realistically, any of these kind of methods you use, someone will be able to find out how you're sending data, and be able to mimic what you're doing and pretend to be the client, and essentially can cause problems for you, can leak some of the information they may find in your server. You never know, but they can essentially mimic your requests or your sockets or whatever, because that data is always available to them, because once again, you're creating these connections from their network, guys. They always are able to monitor these kinds of things. Okay, now one way to do it so that they don't have the ability to sniff and then instantly go and copy that and mimic it and send fake requests or whatever they want to do, or kind of what we're going to be doing as a kind of security measure for this is we're going to be using a similar system to CSRF. For those of you guys that don't know what CSRF is, it's called cross-site request forgery now, or something like that. I'm pretty sure I got it right, but I don't know, so I get some of the letters mixed up sometimes. But essentially what this does is it stops people pretending to be someone they're not. Now, the way we do this is for every new client connection we create, let's say we're doing it through this kind of system, and then we'll go through this kind of system afterwards. So if we're doing it through a simple, direct system, then what we're going to do is, let's say, we'll generate a token, okay, and we'll store it in the server side, we'll store it in a variable, and this token is the special token for this client, okay. Now, without this token, any request sent to this server will be denied. It'll say, okay, listen, we can't authenticate that you're the correct person, so we're just not going to let you do anything, okay. And you may be thinking, what if someone finds out what the token is? Because the token can be left in memory, it can be left in all sorts of places, okay? But most importantly, they can find it if they use sniffing tools such as Wireshark or anything, because you're going to be sending packets out, and they can see what your packets contain. And let's say it's an encrypted packet, there's some that eventually you may run into the problem. People start decrypting shit and just starts getting to a whole nother level. Okay, but um the best way to do this is CSRF. So every five or every let's say every 2 minutes to 5 minutes, you want to reset that token. Okay, you want to say, okay, after 2 or 5 minutes, that token's going to expire. We're going to generate a new one and store it in the database every 5 minutes or every 2 minutes. Now, what this does is it gives them the smallest time gap to sniff the packet, then emulate those requests. Now, obviously, some people may actually succeed in this, but generally they won't. Now, the system isn't the exact same as CSRF, but it's fairly similar to the way it works. Each new client has their own identifier. You could make has their own tokens, or you could buff this up and make it so that each new client has a new token that's a new token's created per request. Now, obviously, it's just completely dependent on how you design your system, but you guys get the general idea, okay? Now, when it comes to this sort of system, it's a lot easier, okay? Now, what you could do is we're going to create another little box, and we're gonna make this a database, okay? And the database is going to be accessed only by the website and the server, okay? Now, what this means is there's going to be no funny business between the client and the database, because the database is very, very important. Now, the database will contain the tokens. So each time you want to send a web request, and that web request is going to obviously go through the server side and the database, then fetch the information, then return it back to you. What we're going to do is we're going to send in the web request token. Now, this token is going to be that little token we generated. Now, that token is going to be once that token is used once, we're going to remove it from the database, okay? So now, how you store it in the database at first is completely up to you. You could maybe make an authentication system that verifies a user's login credentials or something like that. And once it verifies the user's login credentials, it then assigns a new token to the user. And then once the user makes a request, it would return the data they want, as well as a new token they can use on the next request, perhaps. Or you might want to do it however you want to do it, guys. I'm just giving you an example, okay? But that's generally ways you can try and secure your server-sided variables. However, it's a lot more crazy than that, guys. It can be a lot more crazy than that. Let me know in the comment section if you guys have any questions. I don't think there's anything else I've missed, but if there is, please let me know and I'll let you know. Follow my Twitter down below and all of that. Goodbye.